This has been a topic that I've been interested in talking about for quite some time and found a little spot here that I put enough notes together that I thought, well, this was going to make sense, and decided to put it on the schedule. Next month, before I forget, I'm planning on doing a webinar on what do you do when somebody wants to use MTBF. I have to work on that title. It's a little long. And so the idea here is to explore these two different disciplines. And if you're a reliability engineer primarily, well, what do you do with these quality folks? And if you're primarily in the quality side of the world, what's up with these reliability folks and what's their focus? If you're in any other kind of role, engineering or technician or management, it's well, I guess the easiest way to say this is you don't need either of these engineering disciplines. It's really your job. That's right. So a lot of what we do, we bring a lot of expertise to the table. Yet in a well-functioning organization, these two roles really don't have much of a purpose other than to keep things running. And they should be running pretty smoothly. But be that as it may, that's a kind of a future state that we may or may not ever get to. But in the meantime, we may have two different groups or two different types of engineering in our organization. And so what do we do with that? So one of the ways that people have defined quality for many, many years, and it evolves and changes all the time, is does our product or our design or our process or whatever, is it meet the requirements? Is it conform? And even our processes, are we doing this process correctly, for example? But let me ask, is that good enough, right? Is that sufficient given the amount of ambiguity that's always out there? And we're going to talk about this a bit more as we go on, when we get into some of the quality stuff. And then on the reliability side, you know, we're working pretty hard to avoid failures. We're always talking about failure mechanisms and stress strength and derating and vetting vendors and suppliers and materials and understanding the environment and all those other things in an attempt to avoid failures, yet we still get failures. And it's easy to think that some failures are inevitable and really don't matter, and others really do matter. But where's that, as you can imagine along that spectrum, there's a gray area where, well, do we need to deal with this, or should we, or does it matter at all? And there is a piece in there that's a dilemma both for quality and reliability professionals. And then the bottom line here, though, and the way I think about it, and I'll circle back to this again and again, is I don't care what you call it, or when the failure occurs, or what's the nature of the failure, or do we have the right requirements or not, or did it conform? Is it doing what we think it should be doing? All of that is pretty mute if the customer didn't want it, or doesn't expect that, or it doesn't matter what metrics we set up or what measures we put in place or what kind of testing we do. If it doesn't reflect what the customers really want, and this is both internal and external customers, well, what's the point? Are we even getting close to what we're trying to achieve in our day-to-day work? And we're going to certainly come back to this a good number of times. All right, so here's a question for you. You can either use Padlet, and hopefully in the chat stream on GoToWebinar, there's a link to that. You can join that. You don't need to register, by the way, for that. If you do, it'll put your name on whatever you type there, or you can self-identify, as a few people have already done, or you can use the questions tab. So you're in a design team and supporting a design team, you create this cool new widget that every household has to have. Everybody in business should carry a copy of it and use it all the time. and a couple of products go out the door and one of them fails right away. Somebody unpackages it doesn't work, and they call you. Now, how does your organization classify that, right? So Christine in the questions tab saying she would call it a quality issue, and they would go after it, but it could be both. I agree with that. And I'm going to try to send out the notes I get in here. Let's see, and I got a Padlet coming in. I'm trying to keep track of all this stuff. Evan says a quality failure. Both, but my organization calls it a reliability. Yeah, good for you, Paul. See, I have a bias, obviously, but William, you're catching my notion here. But it really, I mean, technically, it's either one, right? And I think because of the audience here is being a reliability group, you're calling it that. Ty, you're just straight off quality, and that's fine. It's some organizations do that, some don't. And I like this one from Lawrence. It doesn't matter. It's an issue to the customer. And I often expand that. If it's an issue to you, if they return it to you, now you have a warranty expense and a replacement, and you have a disgruntled customer. You may lose that customer. You may get some bad publicity or press from them, right? Have all kinds of stuff. And on Padlet, I'm seeing quality, reliability, quality, and a couple welcome everybody coming in. Yeah, could be both. All right, good. Yeah. Now, some organizations define these availability. Now, Gregory, you're getting a little off track here, but it could be an availability issue if you couldn't get the replacement to them quick enough or repaired quick enough. Now, one of the ways I've seen this work is that organizations have different pools of talent, and part of this is that the early failures commonly, not always, but commonly, are related to manufacturing or vendor errors or sometimes design errors, and that certainly can show up in an out-of-box failure. It could be transportation or shipping and so on. And typically, not always, and not in every organization, but in general, the quality team oversees a lot of that evaluation and setup and making sure that those systems are all in place and running smoothly. And so they have a pool of talent that is familiar with those processes and elements of the organizational process. And so they get tasked with taking a look at that first. Now, it's equally possible that the quality team is working on other issues like trying to understand the voice of the customer and understanding how customers interact with the organization and dealing with customer service and training and things like that. And they're also working internally to make sure that we have a good measurement system and calibration systems and all kinds of other tools. And then the reliability team has got the deep knowledge about failure analysis and all of the parts that go into making a product. And so they may be naturally tasked with taking on this issue and solving it and working with the team. Now, both could, right? They both have talent and skills that allow them to deal with an issue, whether it's out of box or at any point in the development process or even in the long life, out of warranty type issues. So there's a good mix of responses and good answers there. So, and it's not given, it's not defined anywhere that has to go to one or the other of the organization, or even back to a sustaining engineering or back to the design team. It could well go back to those people also. All right, so let's talk about quality just a little bit. And I'm doing gross generalizations by far, right? And this is just based on my experience. Quality is a long-standing engineering discipline. There's professional societies around it. There's standards. I'm thinking the ISO 9000 series and quality management practices and systems and auditing and all kinds of cool stuff that goes on around quality. Yet, here's the three things that I think really tie into what quality is all about. And this is based on my own experiences. One of them is in the product development process. The quality team is looking for, well, what are the requirements, right? Early on, marketing and the development team says, well, here's what's possible. But the quality team or somebody with that kind of role comes in and says, well, you say it wants to be, you want to make this box blue. Well, which blue? And how are we going to measure it? And how do we determine how blue is appropriate? And is that the right requirement for what the customer wants? And if you're working with these different teams to set these up, design requirement might be that it has to be handheld. Well, how do you define handheld? I remember the first, it was called a portable personal computer, but its nickname was luggable because it weighed about 40 pounds and had very big handles on the side of it. As opposed to a laptop today that you can, easily tuck in under your arm, or the smartphones we got have as much or more computing power than I had in that luggable. Early on, that computer's design requirements is that a healthy human had to be able to move it from one location to another. Whereas today, the requirement for portable means it's easy to manipulate, move, and carry, and you could use it all day long and carry it anywhere and use it anywhere. My old luggable was restricted by the length of its power cord. But we also, in the quality group, we often work with vendors doing assessments and audits of them, is looking at their quality management programs, and do they have good work instructions? Do they have good skills to avoid latent defects creeping into the product? Are they meeting all of the minimum requirements for marking and tracking and monitoring their processes? And how do they go about evaluating and testing their systems? And even simple things like going in and saying, how do you store the components that are sensitive to moisture? And I remember doing this. I was a design for manufacturing engineer, but had a very healthy role in quality of working with vendors and our own internal assembly systems to make sure that all of those details were evaluated and checked and monitored to make sure that we didn't inadvertently lead to a bunch of latent defects. And moisture sensitive components it's a phenomena where it's called popcorning, where there's a little bit of moisture inside of say an IC, and it goes into a very hot oven to melt the solder and attach it, and that can actually, like popcorn, break open that component. The problem is that little crack or release of that steam that's been created may not be visible at all, and all electrical tests work because it takes time for the contaminants and corrosion to occur. And if you're in a relatively high volume product, you could be shipping thousands of units that are damaged, and they don't really manifest themselves until weeks, if not months later. And so taking care of things like that really could have been a reliability role. And I've done many of those kinds of things as a reliability engineer. But early on, I was working more like a quality engineer and worked closely with the quality teams to make sure that we had shared our knowledge and taught our vendors and assembly teams proper handling, for example, and storage of components. But that's just one example. Is we set requirements for what we think the customer wants, and then we set layers and layers and layers of requirements internally so that at the end of the day, we've touched all the important pieces that allow us to make a product or create an output of our system that meets our customers' expectations. The really hard part is making sure we have the right requirements. And that often is the tricky bit by far. Now, a lot of quality teams that I've run into and have worked with, they focus on setting up procedures and processes and techniques and so on. So there may be work instructions and work breakdown systems and training systems and compliance audits and tracking just about everything from the product development process to the risk management process. And it can be at various levels of the organization, or very, very detailed, looking at one piece of equipment and one particular measurement and putting SPC on it. But we often have just binders and binders full, or databases full of techniques and processes and internal standards. This is how we measure this. This is how often we do calibration. This is what we do. And it allows us to keep the system rolling without having to relearn things every time we come up against a particular issue or process. The other piece of it is it allows us to set up systems that allow us to improve the process and to improve the techniques that we're using. Now, this one reminds me of Deming, and I don't know if many of you or all of you have heard of Deming and his red beads experiment. And he had a big vat full of white little marbles, essentially, beads, and there were a handful of red ones, some proportion of red ones, and then that he declared were defects. And he used it without going into detail. You can look it up. I think there's plenty of sites that talk about it, and there's probably even a video or two of the process. But essentially, it was the process of scooping out these beads was basically constricted. There was defined outcomes and process and speed, and there was some training and so on. But the criteria was that there should be no red beads in the paddle that you're scooping all these pieces out. Well, that was near impossible. And so what Deming would do would get the CEO of the company up there on stage and teach them how to do this. And they'd very carefully get these out and shake off the loose ones, make sure they're all in their little divots. And then he would berate them because there were bad ones there. And he made the point that just complaining and yelling at or cajoling or putting the blame on the operator of a process when the process was not even capable of doing the task was really fruitless. And it was a good way to destroy a culture within an organization. And so the point was is that you focus on the process and you create a process that is very capable of getting the outcomes you want. And it's not that people are part of that process, they execute it, but if you create a set of work instructions that create scrap, you can't yell at them for doing that because that's the process that's set up. And so it's part of this quality ethic or ethos is to focus on the process and improve that in order to get the results that you want. And then the last part is the customer experience. When I was at Hewlett Packard, there was a kind of a major shift within the company and within industry, and later Apple has exemplified this, is that when a customer goes to your website or gets a brochure or sees you at a trade conference or whatever, what's the experience they get? How is that consistent with the unpackaging of the product, with the use of the startup of the product, and then with the eventual value that your product provides them? So engineering every step of that way is more than just common colors and logos. It's look and feel. So if you want to make a high class, very expensive luxury item, you don't package it in a crude cardboard box with a bunch of pink foam peanuts in it, right? It's not consistent with the image that you're trying to sell or to have the customer experience. And so the idea of quality is not just the product in itself, that it does what it's supposed to do, is that even the unboxing is consistent with the experience that you're trying to achieve with that customer. And what's been realized over the last 30, 40 years is that people remember those experiences. And when it's inconsistent, it becomes jarring. and very memorable, usually in a bad way. When it's very, very consistent, there's this nearly unconscious sense that this is really good. This is a good product. Now, even if it's consistently just very, very simple and elegant, it doesn't have to be expensive, but it also has to just work every step of the way. Right? Um, Simple things. I remember one unboxing, we were taking a look at a new product and they had the new boxes for shipping these things and what the customers would buy off the shelf. And we opened it up and there was all the power cords and all the other peripherals right on top. And then it was basically a small computer. And then the start first was way at the bottom of the box. It was buried under everything else. So you had to take everything out to see what you needed to do first. And it was a very, very simple thing, yet it was completely missed in the process. And so one of the quality folks says, well, if you're going to have a great big piece of paper that says start here, that should be the first thing they see. And it's, well, that's kind of obvious, yet we missed it. And the packing directions were you put the literature in first because there was space under the packaging space for that. And then you built it up from there. So it took a bit of a redesign to get the instructions in the right place so that a customer was here with all these bits and bobs and cables and everything else and may never find the start here page. And that may not lead to the right experience that people are looking for. Then again, I'm a long-standing engineer type, and I figure if you have to read the instructions, that's a sign of failure. But that's just me. So those are three things I think of as what characterize quality in general. And and I mentioned it earlier, is one of the things we do is set requirements, and we often are trying to set it as what the customer wants. We're trying to interpret or understand the customer and how they're going to use your product. And one of the ways to do that is go ask them, right? Do surveys and talk to people and do studies and all the other stuff. And we find out very quickly they don't always agree. And so you have to pick which customers you're designing this product for and be very clear about that, both to the customers that this product is for and for the customers that's not for. The hard part is that people change their minds. New products come on the market, new challenges show up, new requirements occur, new ways of using a product or creating value from your product change. These things always change. So it's an ever moving target. And it's what, in my mind, makes quality such an interesting thing, is trying to get into the mindset of the customers in a way that we understand what they really, really need, not what we can really, really do. It's what do they need? What do they want this item or product or solution to happen? And then how do we deliver that? And I think that's a fascinating field, one way beyond my pay grade, but it's one that is vitally important for vast majority of products that go to the market, whether consumer or business to business even. Right. Now, reliability is a little bit different. Some will say that quality, has reliability as one of the characteristics of it. There's, I think, I don't know if it was Deming or somebody else that had 14 characteristics of quality, and reliability was just one of the 14 elements of it. Whereas, of course, I say reliability is all of that quality stuff, but over time. And it's perennial debate with really no resolution to it. As many of you noticed right at the start, they're both important. One of the things about reliability is we like it when nothing changes. The parts coming in consistently are on spec, right? The customers and the way they use it, they don't all of a sudden decide that they have to use this in outer space or in the Arctic or underwater. That it's a portable handheld phone and you use it in your office or your desk or your car, and that's about it. If they go other places, well, that causes problems. Now the environment's changed. We also like it when we have tons of history and we have a product family that's been in the market for years and years and years, and we've got beautiful field failure data, and we understand how customers use it and what they like and don't like, and we can make incremental changes to a product very cautiously and test it out and send it out. The hard part is when we don't have stability, when we're making a brand new product or changing vendors or moving the line to a different part of the world. Our ability to say, is this good or not from a reliability point of view, fades, right? The more we know about how it actually works in the real world, the easier it is for us to say that this very similar product is going to also behave very well. Well, that's where we make our money as reliability professionals, is when any of these things change. And as you know, they change all the time. And so it's identifying those risks from the instabilities that occur in our processes. They are going to happen. We're going to get new vendors. Customers are going to do different things with our products. But how does that impact the reliability performance of our product? Or say it another way, how does that impact the quality of our product out over time as it ages in the customer's use, in the customer's hands? So one of the things we really, really like is when it stays the same, yet we know it's not going to. So how do we deal with that? And that's similar to quality guys. They like it when it all stays the same. Let's see, did I miss a slide? No, all right. The other piece of this is, this was an experience I had when I was at Hewlett Packard. One of the organizations was making very early digital cameras. I don't hazard, they're like the very early dial-up systems, like 300 baud. These early digital cameras were in no way competing with film yet, and they were expensive, yet they saw it as a potential. I don't know why it never actually kept going. But part of what they did in that division that was making these early cameras is they surveyed customers as to what degree did reliability play a factor in their purchase decision. Now, at the time, Hewlett Packard was making these absolutely rock solid calculators and laser printers and things like that. And also all of the test and measurement equipment that had been used by engineering teams around the world for decades. So the brand conveyed a high amount of reliability in the product. And so the marketing folks were saying, does that transfer to this brand new platform for Hewlett Packard? And it did. The trouble is that when that product itself didn't meet that expectation that was built from other products, completely different types of technology, the trust in the next purchase was destroyed. And it wasn't just with the cameras, it was with anything. And so once you make a very reliable product that your customers trust is just going to work, you have to keep that, right? You have to maintain that. And what the survey found was it was like well over half of the influence on the decision to purchase was based on the brand promise that it would be reliable, that it would work, and it would work over time, that it was like the calculators or the laser printers and things like that. And so the reliability piece ends up being, and it's convoluted with quality, right? But customers, when they purchase a product, and there's certain price points where this makes more sense than not, but when they purchase something that is critical to their business or critical to their lifestyle, and they just have to it just has to work, that's where the crux of reliability plays a role. Because if it worked yesterday and it didn't work today, most of us would call that a reliability issue. But reliability in the general sense of its definitions is trust or dependability, is that your customers can count on your product actually working. And if that's broken, right, and it could be not just that the product failed, is that it doesn't perform as expected, then that trust starts to erode. And that's a much bigger hit to your organization than just having a warranty claim. So it's a part of reliability that, yeah, we hit the right requirements and we got the right features in the product, but they have to work over time and they have to work at a level that the customers expect. And yeah, I always think of it as quality with duration, right? And the hard part here is that there's so many requirements, like that color blue I mentioned earlier. And when I found out this one the hard way is that we did some aging. We said, oh, this is a paint and it's susceptible to UV. And if we put UV inhibitors in it, it made it a very dark shade of blue. And that wasn't susceptible to the marketing group. So we aged it. We exposed it to some UV and some humidity and a little bit of heat. And the blue turned into this really kind of icky looking, sickly looking blue. It's hard to describe a color like that. And I couldn't find it either. It was, it's somewhere in this sky that's on this image I got on the screen. And the marketing folks looked at it and said, that's not acceptable. We can't do that. So we changed the formulation slightly and we got a close enough color to what they wanted, but it changed over time. But it is something that was even more pleasant. It was more burnished or more polished looking as it aged. And they said, okay, that's okay. The hard part is that as engineers, we're looking at these colors going, how do we measure this spectrum to detect what is good and bad? Well, we can't. So we ended up using juries, basically, that said, this is a good color, that's a bad color. We did the same for sound with inkjet printers. This is a good sound, that's a bad sound, because sound power or sound frequency didn't correlate to what the humans perceived as good or bad. And so some of the changes in our products really don't matter. They actually make it work better, or they feel better, or they create a pattern. Like if you have some old tools, an old hammer that you've had for decades, the handle grip has got the coatings of your hand oil and some age on it, and it fits your hand really well, and it has a certain feel, a burnished feel, and it's very solid. Whereas you get a brand new hammer that it may not be smoothed over with use. It may be a little bit rough and feels great in your gloved hand, but barehanded, the wood feels different. And so some things matter. Now on a hammer, if the attachment of the head of the hammer to the handle becomes loose, that change matters because now we got this flying piece of metal around the house, which is probably not a good thing. So part of our role in reliability is which of these quality aspects of our product have to maintain the holding force of that head on the handle, but also which ones really don't matter, like the feel of the wood as it ages over time and becomes more polished. Now, if it becomes slippery, then that's a different issue, right? So we have to think through how things change over time. I mean, think of it as stress strength curves, right? We know that the strength, whatever aspect we're measuring, is going to change. It's going to increase in its standard deviation or variance, and it's going to shift its mean. Unfortunately, also the use conditions change, and then some things accumulate damage, things are moving all over the place. So thinking through that as it goes over time is what we do in reliability a bit more than what people think of in quality. Of course, another gross generalization. Now here's a theoretical question for you is, now I've been a reliability engineer without that title, except for as a consultant, my whole career. But I've done accelerated life testing. But as a reliability engineer, as looking at a way to minimize failures going to the field, I focused on statistical process control and looking at, and this one particular application was we glued this metal item onto a handheld device, and if the glue wasn't adequate and cured correctly, a very small bump or just dropping the product lightly even would snap that glue right off and it would come apart. Not a good look for this device. Think of it like a microphone. And so I didn't want to have that failure happening in the field, right? It wasn't critical, the product still worked, but it really exposed the microphone element to other mechanical damage, and that was the purpose of the screen over the top of it. And so we focused on that gluing process and re-look through the techniques that were being used and how do we measure it and how was it stabilized, how was it monitored, how did we put in process control on it. We did all kinds of stuff to make sure that that particular failure mechanism was very unlikely to occur. And we even monitored it with drop testing and were able to tell fairly quickly when somebody new took over that gluing operation and changed something in it. We could detect it. But if we hadn't put in all those steps and safeguards, we would have shipped thousands of those products that would have just fallen apart. We use, as reliability engineers, at least I have used a lot of what could be called quality tools, right? And vice versa. A lot of quality engineers use reliability tools, and we'll talk a little bit about that. Get my slide to change. There we go. So as I mentioned, we often use a lot of common tools, right? Now, design teams set goals and requirements and set timelines, and the quality team may set up a product life cycle, and here's the various reviews and checklists that we need to go through, and then we may or may not create a separate reliability plan. It may be built right into the project development plan. But here's a question for you is, if a prototype fails on a quality test, right? Let's say we're doing some evaluation that is clearly in the realm of quality. They're measuring certain features, functional performance of a product. They're going through, this is, if you push this button, this light should come on, for example. And if that doesn't occur, if they get a failure there, as a reliability professional, should you be involved? Should you work on that? Should you care? So let me pause here. I get a drink of water. And I've got both Padlet open and the questions tab are both places you can hit a quick response. Yeah, Christine, you're right on it. And this might be an obvious one. Yeah, now I'm seeing a bunch of answers coming in. Yes, it may be just a simple mistake in creating that prototype, right? The quality folks or the engineering team may do the failure analysis and sort it out very quickly and yeah, there was a mistake in our directions of how to make this thing. We didn't connect this wire, and so it didn't work, right? That's all fine. As a reliability person, though, is this a common cause failure? Are the other instructions good? What's the check step on this to make sure that that phenomena doesn't get out into the field? How do we know it's working? You know, if my concern of the reliability team is not to have failures in the field with the customer, anything we find during the development process is fodder for due care, right? And I know I've told this story many times before, but in short, an intern years ago worked with one of the HP divisions a couple of years after they'd launched a product, and they had 2 years of field data and all of this returns and failure analysis that occurred. And they had a pretty decent set of what they found during the development process. And they found thousands of issues. It's a complex, say, think of it like an all-in-one inkjet printer that could scan and copy and print and so on. And so they found all kinds of stuff that they wrote down during the development process. And the question was, if we would have solved the next, set of things on the list that we didn't solve, we worked on the list for the things that just caused mayhem and didn't work at all, and we solved all kinds of things. And it was working good enough, but there were still things we could have fixed. If we would have fixed the next set, say the next 30 items on that list, would those made a difference in warranty? Would we have seen an appreciable change in the field failure rates? And so this poor intern, she went through all these records and understood all the things that were found during development, and then went through all the warranty claims and all the failure analysis records and correlated these things, because they were many times in different ways of describing a similar issue. So it took some work to sort it out. And she found that 80% of the field issues had been seen during development. And that if we had gone down the list, say the amount of items they could have checked off or solved over a month, which was on the order of 30 items on that list, they would have cut the warranty claims in half, more than paying for an extra month of working on things. Now, some of those things in that listing, what they found, all these issues that were found during the development stuff, were done on functional tests, or the software team vetting their software and running tests on that system, or a marketing guy just playing with it and saying, well, that's not right, and would write it down. They weren't always in a reliability test. They weren't in the environmental test. Some were found in regulatory tests and then recorded and written down for the team to analyze. Pretty much any failure is gold. But when we set goals and then monitor it, not just set goals and hope we make it, or just checking and monitoring and testing without really knowing where we're going, you got to do both. And both teams tend to do this very well. But it allows us to really make a reasonable product if we pay attention to these things. We also spend a lot of time testing, experimenting, evaluating, auditing, and then a part of that then becomes change management, right? At some point, the bill of materials is locked down or frozen, and any changes after that have to go through a review process, right? If we change a process, how much training do we need? How do we do that? If the design requires a change in component, well, what do we do with the old components? So how do we manage the inventory? Is it important enough we change over right now? Do we rework the products that we've had before? All of those decisions involve both quality and reliability, and both of us use a lot of these same types of approaches and tools to understand how well a system is doing, a product is doing. And so I didn't list all of the acronyms, but the great many ways that we monitor, evaluate, test, and check our design processes, our products, our vendors, and so on. And then both teams really strive towards making improvements. A pet peeve of mine, and when I learned early on in my career, is that if you're a quality or reliability engineer, it's not sufficient to just say, oh, that's not working, you got to go fix that. It is much, much better if you actually help. I was doing an assessment of an organization, and I asked about their FRACIS system, their failure analysis and corrective action system. And they said, well, the quality team has a pretty formal one. And to be honest, we don't like putting anything in that because they're a real pain in the butt and they bother you every day. And they set unrealistic expectations of when or what should be fixed or not fixed. And so we give them a few so they seem like they're busy. But if we give them everything that we have to work on, they make our life miserable. So we don't report it there. We do that just within our own team. We have our own little spreadsheet we hide from them and take care of it. A FRACIS system, a failure analysis system, actually has to help and actually not focus on the process of the deadlines and who's doing what and everything else. Those elements are important, but not to the point where it's overriding other priorities in the organization. It has to fit within what's going on with the team. If the design team is working to meet a deadline for plans going out to vendors for long lead time parts, and you pestering them about corrective action on 15 small items that really don't matter if they're fixed this week or next week, you got to realize that and know when to back off or know when to push forward. the processes we put in place, and Fractus is one of them I've seen over and over again, that's been abused. It's one thing to man a process to make sure that the mechanism works, but it's another one to invoke it so harshly that it's a detriment to itself. And so while quality and reliability want to make improvements, realize that it's in balance with what else is going on in the organization and which of these improvements are worth doing. Not everything is worth doing. There's a cost benefit trade-off here. And being part of that discussion and exploring the alternatives and proposing solutions, or working with the design teams to brainstorm solutions that fit in with their own priorities, with the other things they've got on their table, helps us to make improvements. Now, if I say, that won't work, that's going to break that circuit board if we ship it like that, that's usually not sufficient. Usually I have to get some evidence or make a clear case of why that's important. And if only 0.5% ever even start a crack, and a fraction of those might fail, well, a $100,000 fix to that is probably not worth it. On the other hand, if that failure we're identifying is, we've got the science and the analysis to show that it's going to affect 50% of our products, well, that makes a much stronger case for us to go fix it, whether it's a $100,000 fix or not. We've got a lot more room to move that. So it's not just that we find failures and we have to go fix them. No, we have to go fix the right ones. And that's usually a business decision, which we need to be very tied into. And I think both quality and reliability get that when their processes are working well. Oops. Oops, I went all the way to the back front. I'm not used to using it in GoToWebinar yet, as you can tell. So this is a quick review. Goals, evaluate, improvements, good, I got it. All right, so let me open it up. Are there any tools that are unique to quality that reliability teams wouldn't use, and reliability tools that are unique and that the quality teams wouldn't do? And Greg, I'm thinking about it. I might just switch over to Zoom. I like to have, I didn't know when I signed up for GoToWebinar, they said they had chat, but it's only for me out to you and not between you. So that's why I have Padlet open. So I think Zoom, correct me if I'm wrong, Zoom allows you to chat among participants, and then there's the organizer can chat also. But anyway, yeah, I'm not terribly happy with the GoToWebinar at the moment. All right, so back to the question. What tools are unique that are truly quality and truly reliability? Let's see, material testing for components versus RGA. Okay, I can see that. Although I know as a reliability engineer, I've done material testing early on to see how a particular material will behave with stresses over time. DFMA and PFMA, yeah. Because one's working on the design, one's working on process, they tend to be separated slightly, but you certainly can get involved with both teams. I like that. Yeah, Anchor life data analysis, reliability. There are even customer-facing teams and customer quality specialists that do life data analysis that will, in the shops that receive products back and execute repairs for customers to send it back out, they often have a quality engineer or a statistician available to do the analysis. They may or may not be reliability related, but in general, accelerated life testing, those kind of things are common. Yeah, Weibull analysis and related is typically of reliability. I tend to think of it as anything normally distributed tends to be a quality tool, and things that are Weibull or life data types are typically reliability. It's not hard and fast. Um, Audits. Quality teams tend to, I don't know if they enjoy it or not, tend to focus on auditing. All audit this process, audit this vendor, audit this thing. Reliability, it is a tool that can be used. Reliability teams probably uniquely do accelerated life testing. But as you can see, there's a lot of overlap, and either team can do either one of these things. Measurement system analysis for quality. Now, Gregory, I tend to agree that it's typically a quality function, yet when I'm having problem with products getting to the field that are bad and are end of line measurements, they're saying it's good, that's the first thing I pull out is our measurement system valid? You know, is that working? So as a reliability engineer, I look at the wealth of tools that are available inside quality or reliability or engineering in order to one, prevent problems, and two, to solve them. Now, in general, we're after the similar things, right? But the way we go about it, and I've talked about this many times in this podcast, in this webinar series, is that we influence decisions. The quality manager may or may not have veto power at a design review. A reliability engineer may or may not have vendor approval criteria. They may or may not. It's really dependent on the individual organization. The vast majority of our work in both organizations, in both engineering fields, is to influence decisions. We set up processes and procedures like the product lifecycle in order to guide the sets of decisions that need to be made at various levels of the organization as they develop a product and bring it to market. In the reliability world, we're often working with our knowledge of failure mechanisms to say, you know, that's a risk, or we don't know that, let's go check that out, or this is a way to evaluate that. And the results of those investigations and experiments and discussions is to influence a decision. Do I use this color blue or not, for example? Now, sometimes we write them down in checklists or guidelines or build it into processes that we're using. And sometimes it's in that discussion. It's understanding what we're trying to do, balancing the business elements of it, and saying, you know, this is the problem we need to solve, and here's some options. Or this is a field problem we have. We need to figure out if this is a one-off or is this a tip of the iceberg kind of issue. And let's go do the experiments to figure that out. Because at some point we got to decide, do we need to change this design for this one failure or to prevent many other ones or not? And it's an investment decision. And so whether quality or reliability, again, we're influencing decisions within our organizations. Now, both quality and reliability deal with customers, right? We in some cases, we're advocates for what the customer is suggesting they want. But when you think about it, it's a little bit of both, right? It's quality and reliability. And I think the consistency of setting the expectations from marketing all the way through, if you're saying this is a high quality product, but it doesn't last very long, or it's a high quality product, but it comes in a box that just is falling apart and it's, you know, scratched and scuffed and sloppily made and parts falling off of it, even though it produces great audio output, for example, it's starting to erode that customer satisfaction, and it may just break it when it's inconsistent enough. Now, we can also have a very long, very reliable product, but a very, very poor quality. I'm thinking of those little boxes of Bic pens, right? Hard plastic with a tube of ink down the middle of it and a roller on the end of it. It's a very simple product, and they generally just work. But they're not the highest quality, right? They're not the fancy pens you can get that have beautiful ability to capture your handwriting and things like that. And they don't feel great in your hand either. But it's still a product. and it's so reliable, but it's not something you would give a graduate as a gift, a pen and pencil set from a box of number 2 pencils that have been chewed on and a couple of big pens. Probably not the highest quality of a gift I would give, now that we're in the middle of graduation season here. All right. One of the things that's key to being a very, very good reliability or quality engineer is to add value, right? So if you're going to suggest we're going to do a process FMEA and you need 6 or 8 people to sit in the room with you for a number of hours to go through this process and understand the risks and prioritize actions to mitigate those risks and to avoid them or understand them better so you know what to do, what are we going to get in return for that? How is that going to be helpful for our organization? We need to work through that. The same with reliability. We don't just lay out a reliability plan, and since, well, me personally, I love doing accelerated life tests, but they're expensive and they take a lot of time and they take a lot of samples in many cases. It's expensive to do a bottoms up, multiple stress and create your own model type of accelerated life test. Is it worth doing? Do we really need to know that answer? And if so, well, is it a $500,000 project or is it a $50,000 project? What amount of value is that decision worth given the information we expect to have? And so that guides our investment into it. Now, like I said earlier, if we're finding issues or identifying problems, it's not enough just to say, oh, that's an issue. Is step up and lead the team, get the right people together to go solve it. Lead the brainstorming team, create the fishbone diagram. That's a tool both teams use, and so on. If we can't engineer the solution ourselves, let's get the right people involved to go find the solution that makes sense. And we can add value by framing the problem, by providing the impetus or the leadership to go do it. But the idea is that whatever we do, it's not just to run the test or finish the prediction or apply an SPC to a line that doesn't really need it. But we can do it. It's not sufficient just to do it. We have to have a reason for doing it, and it has to add value. And so those are parts, I think, that are very much in common among our different disciplines. The end of this really is that the title, I've been just general, I think it was first level engineer, engineer level 60, I think it was a title I had at HP. At Raychem, I was a manufacturing engineer pretty much the whole time I was there. They let you put whatever you wanted on your business card, so I changed it every time I ran out of cards, which never happened until I changed phone numbers. As a consultant, I do have reliability in my title, but I spend half my time doing reliability stuff or quality stuff. But it doesn't really matter, right? Whether you're a mechanical engineer, electrical engineer, a director of engineering, at the end of the day, you want to create a product that has the quality and reliability attributes that your customers expect. And I think that's what really matters. So in summary, well, it's this loop, right? We got to deal with all these things, plus the myriad of other things that go into creating products and bringing products to market in order to move forward. So I'm going to pause there. I didn't get to ask as many questions as I wanted to today. I wanted to mention on Accendo Reliability, you can find the Finding Value ebook. You need to be logged in and go to the ebooks section, and you can find my short book on how do you estimate value of a wide range of reliability activities and from different ways of creating value. It's not always warranty reduction, for example. So let me pause there, see if there's any questions. And I appreciate everybody's contributions through the process here. I need to explore Zoom some, see if I can get a more interactive chat window going without having to go to a different site. So with that, I'll pause and see if there's any questions. And I thank you so much for joining me for today's webinar. And next month, I will be talking about what to do when somebody wants to use MTBF or some variant of that title. Chris Jackson is in 2 weeks, has got a webinar coming up, and I'm drawing an absolute blank on what it is. I'm sorry. Let me see if I can find it real quick. Here it is, optimizing service intervals and witchcraft. And he says there's actually a difference. So he writes creative headlines. He also does a really nice webinar if you've seen one of his. So getting a few thanks. Let's see. Function, what do you say now? Download the slides. I'll have the slides up with the recording. It'll be on Accendo Reliability on the webinars page, and underneath Accendo Reliability webinar series, and there will be one with this title, and I'll add the titles there. Yeah. Yeah, he's got a great title. And so make sure you attend. It's in 2 weeks. He starts an hour earlier than I do, which threw a few people off first couple of times. So that would be good, but it should be an interesting presentation from Chris, as they always are. Let's see, I talked about the thanks, bathtub curve, Paul. Oh, more, yeah, I mentioned the bathtub, and Christine had a question or talked about the bathtub curve early on. Paul, the bathtub curve you see typically in textbooks, it looks like a profile of a bathtub, right? And as the early life failure is the flat part and the wear up, that is completely fiction. I don't know of a single product ever that has come anywhere close to looking like that. And the issue is that it's just an idealized mechanism to describe these three different areas of types of failures. The failures that occur because of latent defects that create failures early in the life of an individual item. There's types of failures that a product sees a tremendous overstress, say a lightning strike, and there's hundreds and hundreds and hundreds of ways a product can fail, but all very rare, right? And then there's phenomena of wear up. It just physically deteriorates or breaks down or corrodes or whatever. And the trouble is that products can corrode in the first 2 weeks if a seal is bad, right? And other products can have a latent defect that's imposed during manufacturing that may not manifest itself until 6 years later. And it's still on a declining slope of those failures, that particular failure mechanism happening. And I've looked at dozens and dozens and dozens of field data sets for all kinds of products and all kinds of technology. And nothing ever even came close to looking like a bathtub. And none of them, except one, I had a medical device that for about a 3-month period after it had been in the field for about 6 months, at 6 months of time in the field, the failure rate was pretty soft. It was just relatively flat. You could argue that it was flat. We did some research. We found out that customers had a seasonal use for this product. And so for those after the big launch and a lot of products sold, the vast majority of products were just sitting on the shelf, not being used. And so they just had very little chance of failure. And the few that were being used created some noise in the data that created this flat looking thing. So it's a teaching tool, but it teaches some very bad habits. And one of the biggest ones is this flat part of the curve, which people will assume we're in the flat part of the curve and we can use exponential distribution, which is about as wrong a way of describing anything that happens in real life as anything. And I asked some professors, why do they use the exponential? And they say it's because it's easy. Well, I don't care if it's easy, it's not useful. But I digress. And I'll talk more about that in next month when I talk about MTBF. All right, a couple more thanks. Let me see if there's any other questions. Are there unique measurements that relate to specific product quality other than selling price and product price? Well, let's say it's bandwidth. Like if I have a Wi-Fi router, um, one of the requirements may be a certain amount of bandwidth that that router can pass, and that might be a quality characteristic that the design team says we want to make X criteria, and this is the way we measure it, and it either is or isn't, right? Or it's close or not close, depending on how you measure it. That's a quality issue. Are we meeting the requirements for the specifications that we put on the side of the box, for example? Now, reliability gets involved as if that capability to pass a certain amount of bandwidth erodes with time or changes with time. The expectation, especially recently, is their expectation is those routers will pass way more bandwidth than they ever expected to. And many of us are struggling with having enough bandwidth in our homes. But the idea is that the unique measurement of that feature that's being promised in the product is something that it might be the range of your Wi-Fi router and signal strength and those kind of characteristics. Quality teams often get involved with measuring those to make sure that we're meeting those criteria. Now, reliability may get involved when it becomes, how does that change with time? So even though it's commonly a quality feature, there's still that gray area where it could fall over into the reliability side. Yeah, and Meryl, you're exactly right, and good to see you on the webinar. Dendrik's theorem. I did a podcast with drawing a blank on his name, Sage. He's out of Australia too. Anyway, we did a long discussion about Dendrik's theorem and how relatively infrequently it actually applies. It's very, very hard to get there. It's not impossible, but it's very, very hard to do. And just because the theorem exists doesn't mean the conditions for when it applies always exist. And I think too many people assume that if you have a complex product that's repairable, it'll create a random flat part of a curve. Well, show me the data. And I've even had people say, well, we always assume it's the flat part of the curve, so that's the only data we have. They just averaged everything out and only used exponential. And they said, well, since we use exponential, it must be. And I'm like, I don't think that logic really holds. But anyway, they weren't a client of mine for very long. Yeah, and other times, Meryl, it really is the combination of lots of different failure mechanisms and failure modes, and creating a lot of noise in it. I think one of the issues we have in general is the breakdown of doing due diligence with failure analysis, and but that's again a subject for a whole nother webinar. Let's see, Christine. Yeah. For user questions, issues can also be availability, incorrect results, and also be incorrect directions or expectations that were set that are not consistent with what the product can do. Those kind of things. So good comment. I'm trying to get some of these out. Okay. Yep. Got to understand the physics, understand the failure mechanisms, Meryl. You're exactly right. All right. Let's see. I think it's slowing down there. It looks like the attendance is dropping off quite a bit. People are getting on with the rest of their day, the next Zoom meeting, for example. So with that, I'll go ahead and let's see, I got another question. RCM, reliability centered maintenance. Not the bathtub per se. I think the Nolan and Heap diagrams, none of those, I think there was one small fraction of their data set from a United aircraft maintenance in the 70s and 80s showed something that you squint your eyes at looks like a bathtub. But remember that the rest of the curves didn't, right? They weren't bathtubs. And so the idea though is that you have to understand whether you have an increasing or a decreasing failure rate, right? And then act accordingly. Or is it flat enough that the slope doesn't matter to you, right? You're not going to change your decision because it's not going up or going down significantly for you to decide differently. It's still not flat, but it's flat enough is one way to think of it. So part of the reliability centered maintenance is understanding which of those units are have a decreasing failure rate or an increasing failure rate when you're laying out your preventative maintenance. Now, which ones do you need to monitor and understand which direction they're going? And you also need good failure analysis of what's going on. So it's a little more than just understanding the bathtub curve. It's understanding how your systems are actually performing and getting the data to support those decisions of whether they're due preventative maintenance or not, or predictive maintenance or conditional based maintenance, things like that. Because some things really don't benefit from being replaced or repaired very often. Some actually get better if you leave them alone and don't change the oil as often, for example. But again, I think the subject that Chris Jackson's going to talk about in a couple of weeks is on looking at those service intervals and what really makes a difference. And I don't think he uses the terms reliability centered maintenance, but it really is smacks at the heart of what that concept is about. So be sure to check that one out. All right, so I think I've exhausted the comments. Thanks again, everybody, for joining in, and we'll see you in a couple of weeks with Chris Jackson's recording, and I'll be back in about a month talking about MTBF. I haven't talked about that in a while.